We are going to talk about rainwater collection and green roofs today as part of a low-impact development approach. Jason King and I will lead this class. So I am Chris Webb. I'm an engineer with Herrera. I work part-time out of our Bellingham office and part-time out of our Seattle office, and have done quite a bit of low-impact development design over the past 13 or so years.
My name is Jason King, and I am a landscape architect, work with Herrera, and have been doing site-based green stormwater for most of my career, and specifically have worked on a lot of green roofs, so about 45 projects over 5 acres of rooftop. From extensive, I think the smallest project I worked on was 170 square feet, and the biggest one was about 26,000 square feet.
So this intermediate level class, especially for those of you who have been through these classes before, it's the intent of this class is to give you what we determine to be kind of an intermediate level of understanding of the content and the design and implementation of rainwater collection, new and retrofit. We're hoping that you will learn basic entry-level design and implementation approaches. You know, this will tee you up, hopefully, for doing some of this design shortly as part of your work. We're going to do a quick review of low-impact development principles. The essence of these strategies is about having our built environment replicate the hydrologic and the water quality regime of a native forest. I think that's the ultimate goal, but there's a lot of complexities to get from where we are to there. But you can see here, for example, these percentages show the disposition of rainfall in a typical forest. It's always shocking to see that over half of the rainfall that falls in a native forest actually goes back into the sky. Only about 1% generates runoff. Trying replicating that in our built environment is particularly tricky, but low-impact development is a strong suite of strategies to achieve that, because when we develop land, all of that changes and the portion of runoff becomes significantly larger, and the amount of evapotranspiration and deep infiltration is greatly reduced. And so low-impact development is a set of design and planning techniques emphasizing conservation of natural areas and designing with systems that are much more robust in their ability to replicate those pre-developed hydraulic conditions. And so unlike traditional engineered systems, which historically have been about large centralized detention facilities and big pipes, really low-impact development is about small and distributed. And so that's why we really want to be very diligent on our site and sharpen our pencil and look for every opportunity where we can provide a best management practice which can treat a very small area, catch a little bit of roof water here, a little green roof there, a little bioretention here, maybe make this walkway pervious. And it turns out that if we work at that very more nuanced way, we minimize the concentration of stormwater, and we really are able to mimic those pre-developed hydraulic regime a lot closer than our big clunky centralized gray stormwater infrastructure. Soils, of course, are key to that. Infiltration is a key part of the strategy. That won't be as much of our focus today, but that is key as part of any LID strategy. Right off the bat, start with layout of our site. We want to not just take a traditional development layout and then try and apply LID practices to it. I think a real successful strategy to create systems that are cost-effective is really about rethinking the layout of a site in light of LID and doing the layout of a site with LID in mind. And when one approaches site design with LID, low-impact development practices in mind right off the bat, you come up with a different site layout, and you can come up with a much more cost-effective and elegant design solution compared to taking a very traditional design and then just sort of pushing a thin layer of LID over the top. And so I think it's really successful implementation of the strategy starts right with the planning and working with small practices, managing our stormwater very close to the source. And I think green roofs and rainwater harvesting, I think, embody that pretty well, because we're working right at the roof level, and right as that rain hits the roof, we're working at it right there. Another key strategy, which is often overlooked and also runs against traditional engineering stormwater practices, is to disconnect our impervious surfaces. You know, traditional engineering practices are all about stringing all of our site together in a tight line system, and LID tells us that really we ought to be breaking that up, using more sheet flow, more surface conveyance, disconnecting those pipes wherever we can, and allowing us to use small scale engineering controls here. So we're showing the kind of hydraulic processes that are inherent in a forest and that we're looking to implement with our LID strategies. So the regulatory framework that is the inspiration for this training and for the Stormwater Manual, emanates from the Clean Water Act and flows down from the EPA to the State Department of Ecology through the MPDES municipal permit system, which is a permit to discharge stormwater that goes out to all municipalities of a certain population size, and those permits are required for those municipalities to adopt these requirements as part of that permit. And so that's the regulatory pathway that is the inspiration and really sets the requirements for what we're doing. These are some examples of the number of permittees here for your reference. And so that permit gets updated every few years. Once it gets updated and it's all agreed upon about what's going to be in that permit, the stormwater manual is updated accordingly, and then there's a rolling implementation through, and the dates shown here, with most jurisdictions in Western Washington needing to adopt these standards by the end of December of next year. By December 31st, 2016 at the latest, all of those jurisdictions you saw on the list basically be updating their codes to reflect the requirements for the LID approach that are contained in the 2012 manual. Many jurisdictions are not waiting for that timeline and have already adopted these requirements. Many jurisdictions are already using the 2012 manual for their technical requirements. A whole series of jurisdictions are already fully adopted the 2012 manual. So depending on what jurisdiction you're working in, you will likely need to be working with these shortly. Within the permit, there are essentially these minimum requirements, and within the minimum requirements, they have different implications for LID, and LID is variously influenced by those minimum requirements, but essentially getting at the minimum requirements 6 and 7 for flow control and treatment, but also can be used to meet your minimum requirement number 5. The series of practices that are shown here provide various credits and have influence on both your flow control requirements and your water quality treatment requirements. Our work today with rainwater harvesting and vegetated roofs really are about a flow control, while roof water quality is something that has been measured, and there is an issue there. As far as the manual is concerned, these are flow control issues.